This is the IB book, or the Incredibles book. I'm starting on page 91. This is on free-falling objects and equations you are expected to recognize or know. All right. So the first one is position. Position, we traditionally use S to stand for position. Don't ask me why. T is the variable because it's with respect to time. It's 1/2. G stands for the force of gravity, right? And it's down here, acceleration due to gravity. If it's in meters, it would be negative 9.8 meters per second squared. And if it's feet, it would be negative 32 feet per second squared. I want you to notice this is acceleration, so the unit of time is a square unit of time. Next, and that would be gravity. And t squared plus v sub 0. V sub 0 is initial velocity. Right? For example, if you dropped a ball, in the example down here, we're dropping the ball. If you drop a ball, the initial velocity is 0. If you throw the ball, then the initial velocity is the speed in which you throw the ball. S sub 0 is the initial position. That's the starting point. So if I drop a ball from a height of 100 feet, then the initial position is 100. Okay. There are ways to get very picky about this. For example, how tall is the person who's on the 100-foot platform? Okay, so it will be approximations, or they will be very specific. They will give you the height of the person dropping the ball from a height of 100 feet. All right. Instantaneous velocity is the derivative of position, right? And we use v of t to represent that. Acceleration is the derivative. So acceleration is the derivative of velocity, which would be the second derivative of position. And acceleration is the acceleration due to gravity. Average velocity is just the slope between 2 points. Average velocity is just the slope between 2 points. Speed, so what is the difference between speed and velocity? When we mention velocity, there is a direction involved, okay? For example, you will notice a lot of these values are negative. We have these values negative because we're going towards the ground. So when we talk about position, we're talking about position, how high off the ground we are. How high off the ground we are. So to have positive values, we go away from the ground. Since we're falling towards the ground, the velocity or the acceleration is negative, okay? But when we talk about speed, we don't care which direction we're going. So we take the absolute value of velocity. All right. We already mentioned this. Initial velocity is v sub 0. Initial position is s sub 0. Let's look at the first example here. If a billiard ball is dropped from a height of 100 feet, its height s at time t is given by this. All right, so let's look at the equation. We'll go ahead and copy it down here. So this is the general form. Okay, that's the general form. That's a G. Okay, so we know, generally speaking, G is going to be negative 32. So if you just want to start this as negative 16t squared, right? Half of negative 32 is 16. That's where that negative 16 is coming from. And then initial velocity, since you're dropping the ball, the initial velocity is 0. So this is plus 0t. And then from a height of 100 feet, so the initial position is 100. So that's where this equation is coming from, the negative 16t squared plus 0 plus 100. So that's it. That is the position function describing this situation, right? If a billiard ball is dropped from a height of 100 feet, this is the equation. And the first question here is find the average velocity of the falling ball over the time interval. So what you want to do is find s sub 1, which is negative 16 plus 100, which is 84, and s sub 2, which is negative 16 times 2 squared plus 100. Remember, whenever you raise a power, the negative 16 here is a coefficient. So this 2, the exponent of 2, does not apply to the 16 or the negative sign. So just 2 squared, so that's 4. And then 4 times negative 16 is negative 64 plus 100. That makes it 36. So remember the average velocity, you're just doing the slope between the 2 points. So you find the slope between t equals 1 and t equals 2. So we just do s sub 2 minus s sub 1 over 2 minus 1. Well, s sub 2 is 36, s sub 1 is 84, and 2 minus 1. So 36 minus 84 is what? Negative 48. And 2 minus 1 is 1. So it is falling at average velocity is negative 48 feet per second. Negative 48 feet per second. That's our answer. Then it says find the instantaneous velocity equation. Instantaneous velocity equation. So it's easier once you have the position function, is just simply take the derivative. Instead of trying to memorize that form, just take the derivative of the position function. So v of t is just s prime of t. And the derivative of this is just negative 32t. So that's it. That's the answer to B. Find the instantaneous velocity at 2 seconds. So all we got to do is plug 2 into that expression. So it's v of 2, which is negative 32 times 2. So it's negative 64. So the velocity is negative 64 feet per second. Now, if you mention something like the word falling, right? So you say the ball is falling. So you have to be careful with the language here. The ball is falling. You don't want to put negative 64 because the fact that you mentioned that it's falling, that's the negative value. So at this point, you give it a positive number. Okay, so just be careful how you answer the question. So to answer this question, find the instantaneous velocity. This is a perfectly legitimate answer. A good answer is also saying the ball is falling at 64 feet per second. All right, so those two are the same answer. Right. Part D, when does the ball hit the ground? So this is when does the ball hit the ground? Remember, position is how high off the ground the ball is or the object is. So we can set the position equal to 0. Right? If s sub t equals 0, that means you are on the ground. So we want negative 16t squared plus 100 to equal 0. So that's negative 16t squared equals negative 100. So 16t squared equals 100. I'm taking too many steps. T squared over 100. And 100 over 16 rather. So t equals plus or minus 10/4, right? We're taking the square root, which is 5/2. But keep in mind, negative time means you're going backwards in time. So essentially, you're rejecting the negative answer because it doesn't make sense in this context. So the answer is 2.5 seconds. Also, when you're answering a word problem, hardly anyone says 5/2 seconds. You would say 2.5 seconds. So that's it. So a ball hits the ground. After 2.5 seconds. That's it. All right. And that's page 91. I will be recording the next page in a second.